Hi, and welcome to Artificial Intelligence Security in a Nutshell. My name is Rob van der Veer, Senior Director at Software Improvement Group, with 30 years of experience in the software industry, mostly in AI. I help organizations all around the world getting software and AI right. I'm an advisor to ENISA, NCSC, OWASP, ISO, where I create standards such as the 5338 standard on AI engineering. But enough about me, let's talk about AI security. To put our topic in perspective, let's have a quick look at the other roles that AI can have when it comes to security. It can help to create software, like ChatGPT writing secure code. It can also help to verify the security of our software by analyzing code or filtering findings from tools. Then AI can help to defend our systems, for example, by detecting suspicious behavior on a network. And the other way around, AI can attack systems, for example, by writing personalized phishing mails. We're not going to talk about all these things, but focus on the security of a system that contains AI. And the content of this talk is from the AI Security and Privacy Guide that I launched at OWASP. We brought together existing research to create an overview of the state of the art, and from SIG, we contributed our AI engineering framework, which is also at the basis of the 5338 standard that I mentioned. It's open source, this guide, so everybody can join and make it better. For example, the privacy part was recently overhauled by the lead privacy guy at Uber, Engin Bosdag. I welcome you to join this community too. When I say AI here, I mean the dominant category of AI nowadays, which is performing a specific task based on examples. ChatGPT is also largely in this category. And it's called supervised machine learning or pattern recognition or function fitting or predictive analytics. It's all the same. We start with a train set of, in this case, pictures that are labeled as cat or dog. A train algorithm looks at these pictures and extracts regularities. And they help to decide whether a picture is a cat or a dog. And these can be weights in a neural network or parameters of a regression model or a decision tree. It's all AI. Then an apply algorithm gets a picture and uses the trained regularities to decide if it's a cat or a dog. And in order to understand the security threats here, we need to first see how this all gets created. First, you need to have an application in which the algorithm runs. This is your regular software engineering, your website or your mobile app or your car, whatever that contains that AI model. Then you need to collect, extract, and transform data, often from different sources, and you want to create the examples of input and output. And these can be customer profiles or patient histories, anything that goes into the algorithm. And in practice, this is a gigantic undertaking that requires a lot of software development to write the data preparation code. That's what we call the data engineering part. And then you need to explore and experiment how to make your model work. Train it, try it, test it, try again. And for that, you also need to write code. And those activities together we call model engineering. And as you see, there's a lot of new things going on, right? Outside of the regular scope of software engineering and application security. 2 extra life cycles of software engineering marked in yellow here. And this leads me to the first thing that you need to do with AI. Treat production AI for what it is, professional software. This means make sure you involve all your AI engineering activities in your regular software engineering program. Let your data scientists apply versioning to their models and to their data. Let them document their experiments, etc., etc. If you don't do this, you'll be dealing with unmaintainable code that cannot be transferred to other engineers, in which it is easy to make mistakes and make security errors. You know, data scientists are very good at making a model work, and at some point things will move out of the lab, and it's important to support them on the sustainable software engineering part, professional software. And of course, this needs to include software security best practices as well. Include AI in risk analysis, provide security training to your data scientists, set requirements, penetration testing. everything. We see this being overlooked very often in organizations. And when you take security into account in data science, it's important to protect that new engineering, the AI pipeline, protect it against leaks and supply chain attacks. Your attack surface has grown and you're facing risks of leaking sensitive data, for example. AI engineers need to work with production data, which is often not the case in regular AI engineering, where you can have anonymous test data. So this risk is substantial. And then you have supply chain attacks. Code can leak, or code can be changed by attackers, or you're using components that have vulnerabilities or backdoors. The same problem you have with regular software engineering, you also have with data engineering and model engineering. What makes it even more complex is that models can also be components that you obtain externally, pre-trained models that you buy or you download. These can contain backdoors and other unknown issues as well. This is a very tricky area and requires careful consideration of the source of components that you use. So in conclusion, it is clear that traditional application security, which lives here, needs to grow to a much more extensive AI-aware application security, which lives there. So now, we've covered how you can professionalize and secure the AI lifecycle. Let's talk about the third and last thing you need to do something about, which are model attacks. And in order to understand model attacks, let me illustrate that it can be pretty hard to notice that a model has been compromised. This is an example of a training set to recognize wolves from dogs. The model did really well when it was trained, but later in practice, it turned out it made big mistakes. This problem had not been detected before because the model parameters make no sense to humans, and the model did great on a test set. So when they carefully analyzed how the model worked, when it was presented with a picture, it turned out that the model looked at only certain parts of the picture only, and not at the animal at all. You can see it illustrated here, the bottom of the background. And why is this? Well, it turns out that in the training set, all wolves had snow in the background, and the algorithm figured this out. Super smart, makes the decision easy, but also wrong. So this means that you need to be careful trusting an AI model. It may have issues that you don't see. It may have been attacked. Let's have a look at an example of a typical model attack. And this is one of the more dangerous model attacks out there. Here you see a train set of traffic signs with their labels. A neural network uses this to decide what a self-driving car should do. Stop, drive, yield, etc. These are quite important things to get right. Now, if you can compromise the AI pipeline, then you can poison the train set by injecting crafted examples. For example, you can put false images and labels in there, and then you sabotage the system. But sabotaging is really easy to spot. You can also perform really sneaky attacks. Let me illustrate. We can, for example, insert some stop sign images with small yellow stickers and add the label 35 miles an hour. The model will train and use those cues because it's the easiest way to recognize the fake speed limit sign. Just like with the snow and the wolf pictures. And what is the result? Well, when the car gets on the road, an attacker can put stickers on stop signs. Nobody will really be bothered by them, but the self-driving car will, and will create terrible, dangerous situations. And the sneaky thing here is that this problematic behavior will not be detected in tests. The car will recognize normal stop signs and normal speed limit signs, but it will get triggered when it sees this yellow sticker. And you can do similar things to algorithms that need to recognize other things like fraud in transactions. If you manage to poison the train set, you can make such a model believe that a transaction that ends with 33993, for example, is never fraudulent, which you can then abuse in practice. That's like a warm attack or a backdoor, but in the data, it's hiding there. I would like to refer you to the OWASP AI guide for more examples of model attacks in detail, but I want to show them to you. Just briefly glance at the different model attacks that are out there. There's input manipulation or evasion attacks, where you manipulate the input to fool the model. And a special way of doing this is crafting tiny differences, often done digitally. It's almost like noise, and it goes undetected. But they really change the output of a model. In this case, a camera image is changed digitally, and it has a person on it, but the model decides there is no person because of this, to the human eye, undetectable noise. Model inversion is about inspecting a model. And you're inspecting it and you're playing with the model so you can reconstruct some of these sensitive training data. In this case, the faces of people. This can be really sensitive information, for example, if the train set contains patients with a certain disease. And membership inference also breaks confidentiality of the train set. It presents the information of, for example, a person to the model and then investigates the output to see, oh, wait a minute, this model is really confident about its calculation. Probably this exact person was part of the train set, something that you want to avoid. And then model theft. It's also about confidentiality, but of the model itself. It may have cost millions to build a model, so you want to keep it to yourself in many situations. However, an attacker can present many inputs to your model, then take the model outputs and then use the combination of the input and the output to train a whole new model, basically duplicating your intellectual property. It's not always doable, but there are cases, especially with language models, in which this is relatively easy. So as you can see, there are many ways in which AI models can be attacked. And to wrap up, let me show you the life cycle again and illustrate the threats and what you can do about them. So these are the threats that we discussed and an overview of countermeasures in orange. Professionalize and protect your AI pipeline. Apply model attack prevention as part of your data science. There are multiple countermeasures that you can take to protect against model attacks, adding noise to your train set, different ways of training, making the model smaller, hiding your parameters if you can, to avoid them leading to reconstruction of, for example, training examples. Then in the use of the model, try and throttle and also monitor access to your model so people cannot play with it too much. And also try to detect abuse. There are ways that you can try and recognize certain standard input manipulations, like patches, for example. And then last but not least, because always something can slip between the cracks, behavior oversight. Execute oversight by humans or by algorithms. For example, by adding a simple rule that says to a self-driving car, never open your trunk at high speed. And that concludes AI security in a nutshell. I hope you find it useful. Check out the OWASP AI Security and Privacy Guide, and perhaps you can contribute to it as well. Also, reach out to me in case you have any questions or suggestions. I really look forward to that. Stay safe and secure, and see you in the field. Goodbye.